Hey folks, today we are going to write the code for a simulation, and we're going to simulate, hopefully you'll find this to be kind of fun. First of all, I'm going to replit.com, replit, replit.com. I'm going to go ahead and log in, and I'm going to go ahead and create a new REPL, and we're going to use Python. And I'm going to call it 21 Dice Game. All right, let's give this a try. Now, in our statistics textbook, there was a problem that was presented that said, what if you were playing a dice game called 21, where the object is to get the higher score than your opponent, and except not go over 21. And your opponent already has 18. And there's an interesting question that is asked, is what's the probability of winning if your opponent already has 18? And on average, how many rolls will it take for you to either beat your opponent or lose? So anyways, the idea of how many rolls would it take to win or lose on average, and the idea of what's the probability that you'll win, these are questions that would be difficult to answer if we were just using theoretical math, like the kind you've learned in math class in the past, and the kind some of you will learn in the future. So we're going to try to use a simulation. We're going to use computer software, Python, in order to simulate the situation, and we're going to check out and see what happens if we play the game many times. We're going to record the outcome, and we'll use something like the law of large numbers in order to determine the answer to the questions that were asked already. So the questions about the probability of winning and all that. Okay, so anyways, let's go for it. We're going to start off with a little Python, and we need some randomness, and Python does not have randomness built into it. So we're going to go import random. And then just to double check and make sure that this works, we're going to pretend like we're rolling one die. If we had two of them, we'd call them dice, but we have one, so we'll call it a die. And so I'm going to say die equals, and I think it's something like random dot, I can't remember exactly what it is, let me look it up. Just one sec. All right, so I just realized that this Python editor will help me figure this out. If I just type random and then hit dot, now that I've imported the random library, if I just type random and then dot and then RAN, it shows me what my options are. And let's see here. I'm not entirely sure which one of these I want to use. I either want to use randint or random. I think we're going to use randint for now. Let's try that. Randint, I have to give it an A and a B, two numbers. And I'm going to pretend as though we're rolling dice. So the lowest number should be 1, comma, and the highest number should be 6. Then I'd like to see whether this works or not. So I'm going to print the result of rolling that one die. In other words, this right here chooses a random number, 1 through 6. Die equals sets this variable known as die to that random number, and then this will print it. Let's see how that goes. So over here in the console, this is where the output is. You can see I got a 2. I'm kind of curious what happens if I run it again. 3 that time. I'm going to run it again. 6. I'm going to run it again. 2. Okay, so I'm going to run it a few more times, and it looks like it's working. A few things that I'm happy about. I'm happy that I see a 1 occasionally. I'm happy that I see a 6 occasionally. I'm also very happy that I never see a 0 and I never see a 7 or a higher number. Okay, so this looks like it's working. So if we can roll a die, then we should be able to play the game of 21. Now remember, our opponent has 18, so we've got to roll again and again and again, and we're not exactly sure how many times we've got to roll, but whatever we do, we definitely want to keep track of the total for all of our rolls, and we will do that by doing something like sum equals the previous sum plus whatever we roll on the die. Now, just to have good form in coding, what we do is up here, I'm going to go ahead and put sum equals 0, just to make sure it starts off empty with 0, and hopefully this will work. And supposedly, if I was to do this again and again, I would see the sum add up to a certain amount. Okay, now the next thing is we've got to do this multiple times. So we're going to do this in a loop. And there's two different kinds of loops we could use. One of them is called a for loop, and one of them is called a while loop. We're going to use a while loop because we're not entirely sure how many rolls we need. For loops are really good if you know how many times you'd like to repeat something. But we don't. We just know that we're going to keep rolling until we get better than 18, but not over 21. So we're going to do while. I'm going to go ahead and make up another variable here, and I'm going to call it not done, and we'll initially set it to true because initially we're not done. And then in here we'll do this we'll do this while we're not done. And at some point we will be done. Now, since I want my code to be repeated, in order for my code to loop or to repeat under the while statement, I have to indent all the code. And as any code that I indent, it's gonna do again and again. Now, the thing here is that I also want to randomly roll the dice again and again, or the one die again and again. So I'm going to go ahead and copy that line of code and come down here and hit enter and paste. This way, I can roll the die and then I can add it to the sum. Now, the way the code is written, right now, I'm about to start an infinite loop. So I hope if you're following along with me, do not hit run because it will just go on for infinity. In the old days, it was really bad. Nowadays, this program, I think, will let you stop it. But in the old days, it could just go on, and you had to restart your computer. It was a little scary. Sometimes a wisp of smoke would appear above the computer. Okay, anyways, we don't want an infinite loop. Infinite loops are bad. So let's see here. What we would like to do is we'd like to check and see, did we get over 18 yet? Okay, so if the sum is greater than 18, then we are done. Let's see here. But we don't want to be over 21. So we're going to say if the sum is greater than 18. By the way, if the sum is equal to 18, we're not done because we want to know what's the probability of winning. And if we only got 18, we would not win. So if the sum is greater than 18, and the sum must also be less than or equal to 21. As long as that's the case, then we win, yay, and we can stop. Let's see here. So at this point, we'll say not done equals false because now we are done, and that will stop the loop from continuing. The only problem is that we have not counted to see how many rolls. So we're going to have to add in a count, and we'll do something like this. Count equals 0. Up here, we initialize the count variable with a 0. And then what we'll do is every time we roll, not only will we get a new sum, but we will increase the count. And we'll do that by going count plus equals 1. And that'll just update the count. So at this point, not only will we be done, but we can print a couple of things. We can print I'm going to use single quotes. Yay, we won. The other thing we'll do is print the count. And at this point, you know what? I think I'm just going to print the word count. Count equals, let's make sure we have quotes. Count equal space. And then finally, let me get myself out of the way over here. We will do print count with no quotes. And when we do that, we should get a number. So let's go ahead and run and let's see what happens. So, oh, by the way, what's happening here, the code that I've written so far is enough to get us through one complete trial. I would like to remind you that each time we roll the die, that is known as a component of a trial. And then when we've rolled the die enough times to either win or lose, we call that one trial. I'm sorry, we're not completely done with one trial because we also have to check and see what happens if we lost. But we're pretty close to being done with one complete trial. And in this case, the one trial took 10 rolls. And says we won. Yay. Oh, by the way, it's also telling us, let's see. Oh, you know what it's not telling us? It's not telling us the sum. So let's double check and just make sure that, let's keep an eye on the computer, make sure it's not messing with us. Let's go ahead and print the sum. And we will stop printing die up here. I'll put a hashtag there to make that a comment. Oh, and by the way, while I'm at it, so you can provide evidence that you did this, why don't you go ahead and put your name with a hashtag right here. So that later on when you take a screenshot of this, you can provide evidence that you wrote the code. Your screenshot's going to include your name, this code, and the output, so that I can see it was you that wrote the code, and I can see that your code was working. And then you'll upload the screenshot to Canvas. Okay, so anyways, let me go ahead and hit run. And it says we got a 19, which is a winning score. It says, yay, we won, and it took 5 rolls. Let's try it again. It says we got 20, yay, we won, 4 rolls. Run again. It says we got 19, yay, we won, 6 rolls. 21, yay, we won, 6 rolls. 21, yay, we won, 6 rolls. I wonder if it's ever gonna go over, let's see, what's happening here? Hold on. The REPL IT had a problem. 19, we won. Does it ever go over 21? Come on. Every single time we win? You know what it is? I know what it is. The deal is that it's only printing the times that we got between 18 and 21. So let's go ahead and let's check the other situation. So we're going to backspace. This time we want our, for those of you who've had to do essays before, you know how you got to indent the paragraph? Well, the indentation on our code is really important. These lines, die, sum, count, and if, all have to have one indent, which we do by using the tab key under this while statement. And then all of these lines, not print, 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 all have to have one indent. When we do the next if statement, it needs to have the same level of indent as the if above, okay? In other words, we'll see why in a second. So if sum is greater than 21, then we need to do something else. We can also say not done equals false, okay, because we will be done. We can still print the sum. We can print boo, we lost. And we can still print the count. And actually we'll do it with quotes. Quote, because at this point all we want to do is, boy, I almost want to get rid of this helper thing here. I know there's a way to do it, but I can't remember. Let's see here. We're going to go print quote, count, equal space, and then we're going to go print, and we do just count with no quotes. So we need the quotes to print the word count, and then we need no quotes to print the number. So I'm going to go ahead and hit run, and now we should lose occasionally. 20 we won, 20 we won, 21 we won, 22, boo, we lost. There we go. It does happen occasionally. So anyways, now we've got some code that's written to complete one full trial. And it doesn't matter whether we win or lose. However, we can now keep track of whether we won or lost, and we can keep track of how many rolls. Now, that's getting us closer and closer to being able to answer the question, what is the probability of winning, and how many rolls does it take on average? Okay, either to win or lose, or just to be done with your turn. Okay, so anyways, we're doing pretty good. We do have a little bit more work to do, so I'm gonna take a little break myself here. Okay, guys. So if we want to figure out the probability of winning, then what we need to do is we need to count the number of times we won. So right now, all we're doing is counting the number of rolls in a particular trial. So we need a win count. So I'm going to go ahead and add a win count equal to, let's see here, win count will equal 0 initially, and then I think we're also going to need a total count, just to be safe, equals 0. And the other thing we're going to need to do is we're going to need an ongoing total for the number of rolls, which again was each time we did a trial, we would count would be the number of rolls. So let's see here. Maybe we'll do, let's see, maybe we'll say roll count equals 0. So now we'll use those. Now, what we're going to do is we're going to make it so that we can repeat this code here does one trial, no matter how many rolls are required for one trial. And one trial is when we get to the end and either win or lose on our turn. We'd like to do multiple trials, and the way we'll do that is with a for loop. So we're going to go ahead and make a loop called for, F-O-R, and what we'll do is we'll do it a certain number of times. We'll start off with just a few. We'll do I, for I in range, and I think we'll put the number 10 there and give that a try. And then what we're going to do is we're going to indent all of this code that's underneath that for. We want all of this code to be part of that for loop. So we highlight all of that code and then hit the tab key one time. And then magically everything gets indented. Okay, now what this will do is it'll repeat this over and over again. However, we need to put our win count, tote count, and roll count in here somehow or another. So one thing that we'd like to do is, let's see here, we still want this trial to keep going the way it's going, except what we'd like to do is we'd like to take the, the good news is I can reset that sum. So every time I go and I want to redo this while, I need to reset the sum. So the sum needs to be set back to 0 before I start rolling again. Okay, so I want to take care of that first. The next thing is, I guess I'm going to need to reset the count as well. So count equals 0. And now I can go ahead and start gathering up my totals for maybe win count, okay? So down here, what I'd like to do, this is where we keep track of our wins. So I'm going to go ahead and say win count plus equals 1. And remember, win count was initially set to 0. And what'll happen is every time we go through a trial and we win, we will update the win count to 1. Now, I wanted to do a total count, but I think it's going to be easier just to do a lose count. So I'm going to change tote count to LOSE, lose count. Notice how I have uppercase on the C. That is known as camel case, and it just an easy way to see that it's a separate word. So I'm going to come down here and I'm going to set lose count plus equals 1. And again, that will keep track of how many times we lost. And then finally, I would like to keep track of how many rolls on average overall. So I want to keep track of the total number of rolls. So what will happen is after everything is said and done, after all these if statements, actually right here I can do it. Count plus 1. Count is where we count the number of rolls. So let me think about this. What I'd like to do is, we're going to do this. I have to do it in one of these ifs. Maybe I'll do it in both of these places. So here we're going to do, what did we call it? Roll count. So this is the overall roll count. Roll count will go up plus equals 1. That's if we win. But we'll also add to the roll. Not plus equals 1, plus equals count. So this will keep track of the ongoing count. So let's see here. So roll count for the losing will also go up by this, because we're either going to do this or we're going to do this. So one way or another, we need to add the total count for this trial to the overall count. And then in the end, what we will get, we will unindent all the way back if we can. And then what we'd like to do is we'd like to print the win count. We'd like to print the lose count. And we'd like to print the roll count. And with these things, we're going to have some cool stuff. We'd like to know the probability of winning. So one way we'll do that is like this. Print, quote, probability of winning, colon, space. And then print, and this will be the win count divided by win count plus lose count. And don't forget about order of operations. We're going to need some parentheses here. So I'm going to put parentheses there, and I'm going to put parentheses there, so that I need 2 parentheses on the end here. And this way what will happen is order of operations, I'll divide by those two added together instead of dividing those two and then adding lose count. Okay, I think this is going to work. Let me give it a try. I'm going to hit run. And what's happening here now is supposedly this should be running like 10 times. It should be going over and over again. And does it look like it is? Let me check. All right, so in examining my output, it looks like it only ran once. And I think the reason it did that is because we never reset not done. So up here, we're going to do not done equals true, so that we can restart this. And let's see if that works out a little better. So now I run it, and if I scroll back, I can see all the different trials. Basically, by setting for I in range 10, I caused 10 trials to be conducted. And I can see the results of each trial. And at the end, I can see that there was 7 wins, and that there was 3 losses, and there was 56 total rolls, and the probability of winning was 7 out of 10. 7 winning trials, 3 losing trials, 10 trials altogether, and 7 of them I won. So 70% chance of winning. Now, I can now see that my count needs a little fixing. My total roll count, that should be fixed up. What I'll do is I'll do print roll count. Let's see here. Let's do this. Quote, average number of rolls, and that will be print. Basically, it'll be roll count, which is the total number of rolls, divided by I, which was the I was the total number of trials. So I think that'll do that. Let's go ahead and try that. And did I get average number of rolls? Oh, there we go. Yeah, I think this is working. So average number of rolls is about 6.7. Probability of winning was 40% this time. So we've made some pretty good progress. That's a lot of good stuff. And I'll leave it up to you guys to, if you are having any problems, you're just going to need to go and look through here and double check and make sure you've typed the code correctly. And of course, if it's not working, just let me know. All right, guys, I appreciate your patience. That was a bit of a long one, but I'm hopeful that you find the result to be pretty cool. If your mind is not blown yet, maybe I'll do one last thing before we end. And what we're going to do is we're going to try to do this right now we just did 10 trials. All I got to do is change this number and add in a few more zeros, and I could have it do 10,000 trials. Now, it's going to be a little bit of a problem if you just try running it like that. So what we're going to do is we're going to get rid of some of these print statements to make it so that it doesn't run super slow. So I'm just going to put hashtags in front of these print statements, except for the ones at the very end. So we no longer need the print statements along the way, and they will just slow us down if we try to include them in there. Let me make sure I got rid of all of them. And now, just for the heck of it, I'm going to try to run 10,000 trials, and let's see what happens. So here we go. Run. Okay, here we go. Ready? 1, 2, 3, run. 1,000, 2,000. Okay, it took less than 2 seconds. We did 10,000 trials. There was 7,147 wins. That gives us a probability of 71.47% chance of winning. And the average number of rolls was 5.9. 10,000 trials, blink of the eye. You got to admit that's pretty cool. All right, thanks for your patience.